Okay, so here is a question where we're asked to draw a frequency polygon. Okay, so a frequency polygon is similar to a histogram. The only difference is that we're going to be drawing a line that connects each midpoint on your graph. Alright, so let's start by drawing our frequency polygon, and to do that we're going to first need our histogram. Alright, so all you have to do to get your histogram is plot the values on the x-axis and their corresponding frequency on the y-axis. So the first column would be 4, 4. So I'm going to find 4 on my graph on the x-axis. Then I'm going to go to 4 on my y-axis. And you're going to be using columns or rectangles to represent each value. Okay, so I'm just going to draw a rectangle from 4 Okay, the next one we have 5, 9. So I'm going to go from 5 on the x-axis to 9, which would be here. And I'm just going to draw another rectangle. Okay, after we've done that, we're just going to keep doing that until we have done it for all of the rows. Okay, so that's going to be 6, 3. All right, that one is not so straight. 7, 6, so that's going to be here. Okay, the lines are not so straight, but you get the idea. And the next one is going to be 8, 5. That's going to be here to here. And the last one is going to be 9, 3. So that's going to be from here to here. So to get your frequency polygon, you're going to find the midpoint. But since the midpoint is easy to find for this graph, I'm just going to go ahead and mark them here. So the midpoint would be halfway between the width of each rectangle that you draw. Okay, so if you were to actually use the formula to find the midpoints, they would be here. Okay, once you're finished with that, you're going to use a line to draw. You're going to draw a line rather to connect each midpoint. Okay, these lines are not the best, but you get the idea. Just use a ruler for this part. Okay, I'm drawing it freehand, so it's not going to be as neat. But you get the idea. Okay, once you're finished with that, that's basically it for your frequency polygon. So you're drawing a histogram. You're going to find the midpoints and connect the midpoints using a line. Okay, question B says we're supposed to calculate the area enclosed by the frequency polygon and the horizontal axis. So to do that, what we're going to do is I'm going to put A is equal to. We're going to be finding the area of each individual rectangle, or at least a very close estimate. All right, so to do that, you're going to say half times. Okay, the first rectangle would have been at 4. So it's going to be half times 4. That would be the length of the rectangle. then you're going to multiply that times the width of the rectangle. So the width would be 1. So from 4 to 5 would be 1. Okay, so you're just going to keep doing that until you have done it for all of the rectangles. Okay, the next one that you do, it is not going to be 4. It's going to be 4 plus the next rectangle, which is 9, times the width, which is 1, plus, you're going to write half again, times, that's going to be, all right, 9 and 3, times the width, which is 1, plus half times, okay, so the next two rectangles would be, so we have 3 and 6. Okay, the last two rectangles, and remember to multiply it by the width, which is 1. So it's 1 for all of them. Half times the next two rectangles, that would be, all right, so we did 3, 6, which would be these two rectangles. That's going to be 6 and 5. Okay, so we have one more to go. Times the width, which is 1, plus half and that's going to be, we have 5 and 3 times 1. Okay, for the last one, you're going to repeat what we have here. So it's going to be half times 4 times 1. Okay, when you do all of this, remember you multiply before you do anything else. Or actually, we have brackets, so we're going to work out what is in the brackets, then we multiply. So BODMAS or PEMDAS. All right, so that's going to be half of 4 would be 2. I'm going to put that part in red. So half of 4 is 2. And 4 plus 9 would be 13. Half of 13 would be 6.5. Okay, 9 plus 3 is 12. Half of 12 is 6. 3 plus 6 is 9. Half of 9 is 4.5. Okay, 6 and 5 is 11. Half of 11 is 5.5. Okay, 5 and 3 is 8. Half of 8 is 4. And lastly, half of 4 is 2. So we're just going to add up those and get our final answer, which is I got 30.5. And remember, we're asked to find area, so you have to remember the correct units. So the correct units would be centimeters squared. Okay, number 13 says prove whether A, B, C, and D, E, F are similar triangles. Okay, so based on the information that we're given, we're going to have to choose one of the 3 theorems that we can use to prove that triangles are similar. So that's the SSS theorem, the SAS theorem, and the AA theorem. And we know what the S and A would represent. So S represents side and A would represent angle, sorry. Okay, so I see that we are given 2 sides and an included angle for both triangles. I also see that we are given 2 triangles in each, two angles rather, in each triangle. Okay, so we actually have 2 options out of the 3. We could use the AA theorem, which says that when you have 2 corresponding angles that are congruent, then the triangles are similar. So that would be the AA theorem. So we have 2 angles here that are congruent. That would be one option, sorry. The other option would be to use the SAS theorem. So that says that when you have, or actually you could use the SAS theorem. Reason being, we don't have the measurement for this corresponding side. So the 21 and X would correspond. However, in order to use the SAS theorem, we would have to find out if the ratio between the 2 pairs of corresponding sides are the same. Okay, so I take that back. We actually have to use the AA theorem in this case. All right, so to find the scale factor, so we have 2 scale factors. We have one for when we're scaling up and one when we're scaling down. So when you're scaling up from when you're scaling up from the smaller triangle to the larger triangle. All right, so to find that, you're going to choose one pair of corresponding sides, and you're going to put the larger corresponding side over the smaller corresponding side. Okay, I see where I have one pair of corresponding sides. That would be 24 and 16. So to find the scaling up scale factor, I'm going to put the larger length or the larger corresponding side over the smaller corresponding side. And we would get 24 over 16 is fine. But we can also break that down further. In its simplest form, this would be, okay, so to break it down into its simplest form, you would have to find the HCF of the numerator and denominator. So what's the HCF? The HCF would be the biggest number that can go into 24 and 16 without leaving a remainder, and that would be 8. So 8 into 24 would be 3, and 8 into 16 would be 2. So we can break this down into 3 over 2. Or if you want, you can write it as a decimal, which is perfectly fine. You can write 1.5. Okay, to get the scaling down factor, the scaling down scale factor, the scale factor you would use when scaling down, so this is when you want to go from the larger triangle to the smaller triangle. Okay, and to find this, you're going to put the smaller corresponding side over the larger corresponding side. So it's going to be 16 over 24 when you're scaling down. And that is going to give you, okay, so again, we can break this down into its simplest form. That would be 2 over 3. Or you can write this as 0.7 to 1 decimal place. Okay, the next question says, find the missing length. So to find the missing length, which is x, we're going to need to decide which scale factor we use. Now, we want to find the corresponding side in the smaller triangle. That means we're scaling down. So we're going to multiply the known corresponding side, which is 21. So 21 and x correspond. So to find the unknown corresponding side, we're going to multiply the known corresponding side by the scaling down scale factor. Okay, so it's going to be x is equal to, personally, I prefer to use the fraction form, so I'm going to use that instead. So it's the known corresponding side, so the side that corresponds to our unknown side, in other words. And again, we're using the scaling down scale factor because we want to find the side of the smaller triangle. Okay, so we're scaling down, in other words, 21. I'm going to use the fraction form, which is 2 over 3. All right, so I can say 3 into itself one time, and 3 into 21 would be 7. So that would be 14. So 7 times 2 would give us 14. And that's basically it.